Alright, let's continue. Let me open the table of content first. Okay, we are in this chapter on homework code section. Let me open that. Okay, wait. I kind of want to try this out first. So maybe let's try this. I guess. Chapter 13, right? Right, chapter 13. Chapter 13. VA.C. What VA means? Can we might get different address here, but I want to see if the stack address is longer than the heap encode. I guess. Let's see. Well, or maybe we can call this X, okay, and then we use malloc, right? Okay. Okay, maybe something like this. Malloc size of yeah, okay, and then print out all of this. Okay, all right. Location of code. Main, something like this, and then heap. M, I guess, right? And then stack address of X, okay, and then don't forget to free the malloc here with okay, free return void, so there's no return value for free. Okay, and then let's try this first. Pedantic. Okay. Main. Aspect argument avoid but has to type. Okay. What is this? LS. Is that what we should use? I mean, okay. Function pointer. Interesting. Okay. It is a function pointer. So, aspect argument of feature. Aspect argument of feature T. If I remove this pattern, take. Okay. Interesting. Why we cannot do this again? Now let's try that, I guess. Oh, okay. Alright. Okay. Okay, and then maybe I should cast this to void. I don't really like casting stuff. Function pointer to object pointer type. Okay. Yeah, it is from Pedantic. I cannot do that. Let me check. C programming print out function pointer address. Address of a function. Alright. Okay, let me try on my system. Okay. So I disable the randomizer, I guess. What is it called? Set arts, okay. I cannot forget. How to do this? Maybe something like this. Test M and x66, and then use this. No randomize. And running CSH, for example. Okay. Okay, interesting. Hello, ping pong pong. Welcome. We are still learning about the operating system, 3ECPs, and currently on chapter 13 about address space for memory virtualization, and we are taking a look at this code. Yeah, that's basically it, I guess. I want to check about the memory address for the function. What is it called? For this function address, and then heap address, and also the stack address, I guess. So there is that. This is it. Oh. Yeah, maybe this one first, and then this one. And then this is the last one, maybe. Something like that. Let me try adding another function. Maybe something like that. Compiling this, okay. I am not sure how to resolve this warning yet. Okay. Alright. Fine. Okay. Looks like this one first. The main fun, something like that. And the main function first, and then the function, and then the heap, and maybe the last one is the stack. Maybe something like that. Good not. It's been a while I didn't join your stream. Thank you. Okay, okay, maybe something like that. So the stack is at the bottom of the address space. From this you can see that code comes first in the address space, then the heap and the stack is all the way at the other end of this large virtual space. All of these addresses are virtual and will be translated by the operating system and hardware in order to fetch value from their true physical location. Okay, so where is it? I think, yeah, maybe this one. Figure 13.3, example of address space, right? There's program code, heap, and then stack. So, interesting. Is program code always the function, memory, something like that? So let's say that we have a bunch of memory, something like that. Let me check. Yeah, I'm kind of curious. How do we print the memory address of a function? Let me try print. Printing function address, okay. How to format a function pointer? Can be used with void, right? And after conversion with other object pointer. Cannot be used with function pointer. Which version of GCC did you use? I mean, this person used. I mean, I've tried this, right? Well, I also have Pedantic here. Let me move that. Oh, okay. Maybe it is from the Pedantic. Alright. Interesting. So it is from the Pedantic. Okay. Yeah, my bad. Not from this flag. WR flag. There is no format specifier for a function pointer. Right, because of Pedantic. Let me check this. Right, using Pedantic and W. Oh, hold on a minute. Let me try. Oh, okay. So must be pedantic and W all. Alright. Okay, interesting. But non-standard. Is to access the bytes making up the pointer using character type. It is undefined behavior. Okay. Okay. Then this one. Sample output. Okay. What is this? Okay, it looks like there is no easy way to remove the pedantic warning all. Okay. For now, I guess it's fine. Maybe. Okay, this one. From what? Main function. Func2. I mean func here. And then heap. Notice the difference here. And then there is stack. Okay. Alright. Okay. Maybe I can run something like this other than going into the interactive mode, something like that. Okay, right. Okay, we can also use this, I guess. Let me put this in here. And the compiler. Execute like this. Set outs this error make what is it called? Disable the randomization of virtual address space. The randomization of virtual address space. Be something like that. Okay. And then let's take a look at this one. Create a little program that use a certain amount of memory called memory user.c. This program should take one command line argument. Okay, one command line argument. The number of megabytes of memory it will use. Megabyte? Oh, okay. I think that's a lot. Yeah, for a simple program, megabyte is a lot. Okay, and then memory user.c. Okay. The program should do this indefinitely or perhaps for a certain amount of time, also specified at the command line. But previously, the program should take one command line argument. One command line argument. But this one also specified at the command line. So are we using the same argument for both the array allocation and what is it called? Array allocation and the program runtime, I guess. Maybe. Now we're running your memory user program also in different terminal window, but on the same machine. Run the free tool. How do the memory usage total change when your program is running? But when you kill the memory user program, do the number match your expectation? Try this for different amount of memory usage. And when you use really large amount of memory. Okay, well. I'm assuming we can use variable length array or malloc, I guess. Maybe we can use malloc. Alright. Now argument count and then argument vector, or you can also use something like this. I mean, if the array going to a function, the array will decay into the pointer. So this is also a valid representation of the array of pointer. right? Whatever you like, I guess. And then I need to check. Oxy not equal to, I guess, because the first argument is the script name. If that is the case, then maybe let's just print out what is it called? Alright, something like this. Need one argument, and then using the argv0, something like this, return 69. Chapter 13, okay. Need one argument. As we can see in my shell prompt, we also print out the exit code. It is 69. Nice. Okay. And then it should allocate an array and constantly string through the array. Searching its entry. If that is the case, yeah, I need to I need to convert the char array here into the, what is it called? Into the number. I mean, in case anyone wondering, this is something like this, I guess. We read the array script first, and then we read this one. If I understand correctly. Oh, wait. What happened if I do this? Yeah, I'm just trying out. Okay. Right. Invalid use of array with unspecified bound. Right, second argument of min should be char pointer. Okay, right. There's a difference between doing this and doing this. If I remember correctly, this is related to precedence, operator precedence, or something like that. The array subscript here take precedence over the asterisk or the dereference operator. Something like that. Well, I can write it something like this, I guess. to make it easier to understand for the newcomer. So basically this means that we have an array of pointer. To char, I guess. Okay. Alright. Yeah, I know there is a toy. But the problem with a toy is that it is hard to handle the error. See? Except that a toy does not detect error. So that is why I'm trying to use strtool here to convert the string to a number, something like that. Okay, let me check. Wait, okay. Alright. Long, okay. We have long. So they call this limit. Maybe. Okay. No, not that one. Argv1 and pointer. And the PC support strtool stores the address of the first invalid character in end pointer. Oh, okay. Strtool stores the original value of nptr in okay, so I think we need nptr2, right? Okay. This looks like a pointer of pointer. Okay, so maybe something like this. Oh, sorry. And then nptr, right? And then paste decimal. Maybe something like that. And then what is the return value here? Oh, there is error now. Errands. Okay. Maybe you need to add error here. Equal errands. str tool. Oh wait, let's use p error I guess. 69 else if if nptr is not null terminator and nptr is null terminator, on return the entire string is valid. If there were no digit, the first invalid character in nptr. nptr maybe something like this, not equal null terminator, which means it is invalid character. I guess. Or maybe using printf. Valid character. For number, maybe something like that. Return 69. If there were no digit at all, the tool stores the original value of nptr in. Okay. Store the original value. Maybe we should check this for what is it called? Something like this maybe. So if the original value of nptr of nptr, I mean the original value of nptr in nptr and return 0. Oh, okay. That means there is no digit at all. Okay, so maybe we can do something like this. I mean, if it is not returning 0, does that mean there is some digit in there? Maybe equal nptr. Okay. I feel like this should be here. Character for a number. Okay. Maybe something like this. Let me try compiling this. Okay. pointer and integer. Oh, okay, so pointer and integer. So maybe we should do something like this. Wait. Pointer and integer. Okay, no, not something like that. Pointer and integer. Oh, interesting. So I do this. Okay. So basically we need to dereference again. Or yeah, I can also do something like this. Right? Unused variable. F. Oh, long. Okay. Let's try this. Print out the limit too. Okay. Alright. Okay. Character format. Okay, the return is 0. But if there is, what is it called? Some non-character there, it's not gonna be, what is it called? It's not gonna be catch in this condition. Alright. Okay. Store the address of the first invalid character in ENPTR. That kind of make me wonder. Okay. So if the first character already invalid, we are not gonna evaluate the rest of it. Alright then. So so we also handle the first invalid character. I assume it is something like this, maybe. Printf first something like that. And yes, okay. Alright, first invalid character. Okay, something like that. And then allocate an array and constantly stream through the array, touching each entry. Okay. I mean, should I put this at the top? Maybe. Usually people put the what is it called? The declaration at the top, right? I mean, it is personal preference, so just something to keep in mind. When run, it should allocate an array and constantly stream through the array, touching each entry. Okay, so maybe I'm just gonna using the integer, I guess. Malloc. Limit time size of array, okay. And then maybe we're using a for loop here. E less than limit plus I, and then can constantly stream through the array. So maybe we put something like this. Putting the number in the array, and then should we sleep for 1 second before continue? Okay, let me check. Okay, 10 seconds is a long time. Right, okay. Yeah, I don't really want the program to run indefinitely. So let's also use the, what is it called? The command line argument as the number of time we need to run the program. and that kind of make me curious. Okay, without sleep for 1 second, it's gonna run immediately. Gonna finish immediately, I mean. Okay. Number of megabytes of memory it will use. Oh. Yeah. Let me check Wikipedia. Megabytes to maybe it is this one megabyte, right? The decimal representation that we take a look previously. I mean, there's also binary representation. The B here, gigabyte, maybe byte, and so on. Okay, yeah, that's a lot of byte. So I'm assuming if we want to really have the megabyte, we need to multiply this by, we need to multiply the argument by its mass. Okay, maybe yeah, that's a lot for a simple program that only add an integer. It's in my system is, what is it called? I think 4 byte. Yeah, that's quite a lot. Well, let's find out. In megabytes. Okay. Emitter. That means rather than calling this limit, maybe I should call this what is it called? Input, I guess. And then put the limit here. Input times I'm assuming this is 1 million, maybe something like that. Right? Oh, wait, I kind of forgot. No, not that one. Python power of symbol. Oh, we use double asterisk. Okay. Right, it's the same. All right. Okay. Convert the input into megabytes. Then putting that here. Okay. I guess let me print. Name it. No, not name it. Name it -1, I guess. Undeclared. Oh, right. Forgot the semicolon. In, okay. Use long instead of the in. Right. Okay. Alright. So do we add sleep? Yes, gonna be a long time. I don't think I need sleep, but well, because again we're using megabyte in here, not byte. Yeah, let's terminate that. Compile. Okay. But if not using sleep, it is too fast. Can I use sleep but in millisecond rather than second, maybe? Let me some this in milliseconds. 2 milliseconds, right? Yes, after project started to find you sleep. Oh, interesting. Microsecond. So you will have to multiply the input by 1000 in order to sleep in millisecond. Has since been duplicated and subsequently removed from project. For new code, nanosleep is preferred. Nanosleep suspend the execution of the calling thread until either at least the time specified has elapsed or the delivery of a signal has triggered the invocation of a handler in the calling thread or to terminate the process. Okay, interesting. Nanosleep. Okay, this is the example. Why are we putting this in the loop? Why do they keep deprecating simple function for complicated function? SF cannot do nanosecond while nanosleep should. Even microsecond precision is not realistically achievable. Oh. Nanosleep. Nanosleep. High resolution sleep. Oh. Okay. High resolution sleep. Interesting. And it is a system call, not library. Okay, that's kind of concerning, but okay, compared to sleep and U-sleep, nanosleep has the following advantage. I mean, system call also change the mode, right? From user mode to kernel mode. So if possible, I don't really want to use system call, but well, it provides a high resolution for specifying the sleep interval. Specifies that it does not interact with signal. Easier. Oh, and it makes tasks of resuming a sleep that has been interrupted by a signal handler easier. Alright. Do I want to use nanosleep? That feel like overkill. I guess. So yeah, I'm just gonna using sleep for the sake of this. What to the memory usage? Okay. See, while running your memory user program, also different terminal window run free, right? I mean, if it is too fast like this, I'm not sure if we can use free tool to check the memory usage, So I need to, right, 100 megabyte, starting to slow down a bit, I guess, but it is still less than 1 second. Now this one is 1 gigabyte. Oh yeah, around 2 seconds. Okay. Oh, okay. Did you see that? Is my calculation correct here? I mean, let me check. Calculate to calculation by 2. Yeah, but let's say it's 1,000, right? Bytes to make a byte converter. Oh, wait. How do I... Okay. This one, right? So if it is 1000 megabyte, okay, 1 million. Okay, 1 gigabyte. And for some reason, my RAM usage is more than 1 gigabyte. Interesting. Okay. I guess I will continue this on the next session. Hello, Tandang. Welcome. Bro, where are you from? I feel like I recognize your accent. I'm from Indonesia. The actual Indonesian. AI. Actual Indonesian. Okay. So yeah, I'm from Indonesia. Okay. I think I will experiment this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.